Welcome, this is Tech Ed Kirsch. I'll be giving you an overview of how hardware is done and designed by electrical engineers in the industry. You'll understand all of the 12 major processes, the 12 major phases in hardware and printed circuit board design for consumer electronic products, for hardware in general. This is not your standard maker board. There's a lot more that goes on behind the scenes that is business related, business specific, team specific, all right? Not just individual worker or hobbyist or individual professional, okay? Go on this journey with me. I will show you hardware from start to finish, from A to Z, from concept to completion, from mind to market. This is what companies are looking for and what you need to know to succeed as a hardware engineer. So, like I said, we're covering the phases. This is where you master complete PCB design process from concept to production. With a comprehensive step-by-step checklist, you'll understand the tools involved as well. So, starting with the first phase, it's initial planning. You have a mission, a scope, and requirements. This is the most important step of all hardware design. Everything needs to meet the requirements, the mission, and the scope. If it doesn't, the engineering needs to be changed or updated. I'll repeat, the initial planning phase is the most important part, not the PCB layout, not the schematic capture. Those are all very important, but this is the most important. Why? Because when you have a product you need sold, or when you have a mission you need to achieve as a business or company, if you're not achieving that mission, you need to change what you're doing. If your product is out of scope or not within scope of what you are trying to do for your company and your business to make money and for customers to buy what you're selling, then you're out of luck. The engineering needs to change. Everything needs to change. And what about the requirements? The requirements say customers only buy the iPhone, or they only buy the red version of the laptop with GDDR6 or whatever. Then customers is what keeps businesses afloat. Cash flow. The cash flow is the lifeblood of any businesses of any business. And customers determine that cash flow by buying what they want. Okay? And to do that, to make customers happy, you need to meet the requirements. So if people don't want the wrong phone and they want a specific phone or whatever, or if you can convince them to buy a specific phone or product and they're willing to buy it, then you're in business. Then you're a mullah. Then the business can thrive. Then you can hire employees and do more. And to achieve that, you need to meet the requirements. So you see, while everything else is important, everything else supports, everything else rides on top of meeting these. So I think I've driven home that point. Number 2, detailed specs. Once you've established your initial planning, your mission, scope, and requirements, you have detailed specs. And don't worry, I am going to go more into detail about this, but don't worry about it. Initial planning, your detailed specs support and set your benchmarks for your features and capabilities that will meet said requirements. Okay, there we're talking about voltages, currents, temperature, ambient temperature that your board will be able to be in, environments, humidity, specific situations and circumstances, voltages and currents that the board needs to be able to support, the chips need to be able to support to make this product, that the product needs to meet electrically, mechanically, features wise. It's got to have certain colors, it needs to have certain light indicators, all this stuff. And these all still lead back to requirements. The next part is library management. This phase is library management. Like Tom Hosher says, he's the primary author of the IPC 7351 version B. He says all successful all perfect PCB design, it depends on a ECAD library, something like that. I wish I could quote it better, but that's what he told me in a discussion that he and I had a few years ago, and that's what he has on. You can find him. And what he says is you've got to get the libraries the schematic symbols, the PCB footprints, all that stuff right and down pat. Okay, you cannot skimp on this. Your parts need to be perfect. Anyway, so this is where you gather all your parts for schematic capture, PCB layout, your footprints, your 3D models, and everything, because a PCB is just a bunch of components connected to each other electrically anyway. All right. Now, for a schematic design, once you have all your components, you design the schematic. Well, really, this should be called schematic capture and / design. Why? Because there's a difference between design and capture, between schematic design and schematic capture. Schematic capture means an engineer who can open up a software and capture or put blocks together, put symbols together to match a design. But the design itself, that comes from creativity, knowing electrical and electronics engineering, Kirchhoff's voltage law, Kirchhoff's current law, applying different electrical engineering foundations and principles, mathematical formulas to come up with a solution, an electrical solution to a problem that meets certain specification requirements and a mission and scope, initial planning, phase 1. Okay, so just wanted to throw that in there in a job description. If you see schematic capture, that doesn't necessarily mean that you have to design the electronic circuit. But that's a whole other topic. Okay, phase 5. Here is the PCB requirements, defining the stack up and routing rules. This is where you talk to your manufacturer and set up your rules. Then you have board setup, floor planning and component placement, where you organize where you're going to place your components. Okay, so I've covered the first 6 phases, and you got a general idea of what's going on with them. And I'll go into more detail within each phase, like the specific tools you would use later on in later videos of the series. At this point, I'm taking a little break and letting you know we have 6 more phases to cover, and I'm going to switch over to my document because they didn't show up in my PowerPoint. All right. Okay, so I have switched over to my document to cover the next few set of phases. We've covered phases 1 through 6, and now we have phase 7. Now, this is a document that I walk my one-on-one students through when they get into my coaching program. If you're curious about that, click the link in the description below or around this video somewhere, and I can get you, if you have questions, if you want to get professional training in hardware and PCB design, then you can hit me up. All right, so let's get on with phase 7. Phase 7 is routing. Once you've placed all your components, done appropriate floor planning, this is where you have things like layer setup, IBIS models, the whole 9 yards, and I cover in detail all the kind of tools you'll be using across the electrical engineering CAD landscape. All right, then you have phase 8, where once you've routed your traces on the printed circuit board and the layers and all that stuff, done your EMC, EMI, best guess and practices with constraints and all that, then you have design rule check and post-route verification. This is PCB simulation, essentially. Design rule check, or DRC, is where you check and make sure that you place all your components correctly, make sure you don't have any major errors or issues, and then your post-route is once you have pre-route and post-route, where you could do signal integrity analysis before routing using the Manhattan distance of traces that don't exist yet. Don't worry about all that. And then post-route, after you're done routing, you can do a signal integrity and EMI simulations again using various tools to verify that the design is routed properly and won't have signal integrity issues. You also have things like design for fabrication, a design for assembly, design for test, design for cost, EMI analysis, on all that good stuff. All right. Once you've finally routed your printed circuit board and it's passed all the checks for any mechanical, signal integrity, electromagnetic interference issues, and high-speed signal issues, and it's passed all those, then you're ready for finalization. So inspecting the PCB, final verification, 3D models, 3D collision, board cleanup. Also be PDN simulation, power distribution network simulation, which would really be in pre and post route verification, phase 8, but either way. Okay, then phase 10, Oh, once everything's good, then you're ready for phase 10, where you do packaging and ordering the design. Okay, this is where you got to get your Gerber files, your ODB++. You add specific notes for the manufacturer to follow, like the color of the solder mask, the type of metal, like whether you do gold plated or silver plated on your pins, your pad stacks, okay, on the PCB. Version control, submitting files to the manufacturer and everything. If anything changes, you need to resubmit the full file package sometimes to the manufacturer, a lot of times. All right. And then you have phase 11, which is technically not part of the PCB design. This is after you've manufactured the board, got it fabricated and assembled, brought it back in-house, and now you're doing testing. Okay. Once the board passes testing and tests properly, works, then you're ready to say, hey, this board is good for production. We've verified in the lab. Oh, and based on our tests and tweaks, well, based on our tests and results, we need to make some tweaks to design, blah, 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 blah. And now it's good to go for production and release. Okay, so yeah, that's pretty much all the phases of hardware and PCB design. For more in-depth details about each of like the kind of tools in the phases, then you're going to want to check out my other videos in this series where I just give you the breakdown. I spill all the information. All right, the tools you're supposed to be using, what's in the minds of these engineers when they're designing hardware at the team and enterprise scale. All right, thanks for watching this video. Oh, and thanks to our sponsor Altium for sponsoring this video. Altium Develop is click the link in the description below for Altium Develop. Why Altium Develop is because to meet things like your requirements and all of these different phases, you're going to need some kind of software that handles everything. So far, the only software I see hitting all of these phases is Altium Develop's new ecosystem and platform. So you're going to want to check that out. Click the link in the description below. It's no joke, especially the requirements part. But anyway, that's for another video. That'll be part of my, it's definitely going to be shown in as one of the key software to use for each of these phases. All right. See you in the next video.